Okay, so factorising by completing the square. There's not heaps of these types of problems on the test, but we still need to make sure we're looking at exactly what we're doing. Remember that it's just 3 steps. So I complete the square, then I use the perfect square rule to factorise the first part, and then I use the difference of two squares rule to do the last part. Practice, practice, practice here. So if I am looking at any sort of problem, just remember that whatever you add by completing the square, you must take away, because we want our equation to stay equivalent, and then you can continue to factorise using our special products rules. So if you're not confident with the special products rules, don't move on to this. I want you to practice the other ones first. It's more important. If you haven't learnt those, you're not going to have full grasp of this concept. Okay, so let's just break down an example into the 3 steps. So the first thing I need to do is complete the square, and that means that I need to look at my first two terms, and then I add something, always add, then that part makes up the perfect square, and then I always take away the same amount, so whatever that is, and then I keep whatever my ending variable is. So that whatever I add there is always going to be half of this squared. So I can put it in, and I've got 8 over 2 squared, 8 over 2 squared. The reason why I've left like that is because I just want you to be able to see exactly what's going on. Then when I move into using the perfect square rule, I bring over the first part to factorise. I just actually use that and that, right? Because I know that I'm looking for it to be a plus b all squared or a minus b all squared. So I'm going to look at it, and I've got x. Now, the sign comes from up here, so this sign carries down, and so therefore I have a minus, and 8 over 2 is 4 squared. Okay, at this point, if you are not sure, you should expand it and see if it's going to equal this part up here. So I've got x, imagine that I have another bracket here with x minus 4 in it. Okay, so I've got x by x is going to give me x squared. Minus 4 by x times 2 is minus 8x. And minus 4 squared. 8 over 2 squared is what I've added. So that's the same. Now I'm going to expand this. So I've got 8 over 2, which is 4. And 4 squared is 16. So I'm doing minus 16 plus 9. You must always do the plus here and the minus here. If you have a plus here and put the minus there, well, you're not going to end up with a perfect square here. And you're not going to have a difference of 2 squares, because this might end up being bigger than this. Or if you've got plus and plus, right, it's going to be a plus, and you're not going to have that difference that you're looking for. So 16 plus 9, that's a negative, remember. So what I've left with is 7. So I've got, that's the same as x minus 4 squared minus 7. I've now got my difference of 2 squares. Remember that 7 is the same as, I could say surd 7 times surd 7 equals 7, right? So I can actually make it as surd 7 squared, right? So my actual squared number for the second thing there is the square root of 7. So I'm going to end up with, in my first bracket, always have x minus 4, always have x minus 4 as my first part. Whatever that is in the bracket, unchanged. Then I have the plus minus, and then I have the second term. So the second term there is 7, well actually surd 7. So surd 7, surd 7. Okay? If I can then simplify, great. But if I can't, that's also fine. So if I have a surd, even though you know that this is a number and this is another number, don't combine them together because they're different. Okay? They've got a surd there. You're going to end up with a completely long, ridiculous decimal. You don't need that. Leave the surd in. Okay? That's what we were looking for. If you got through all those steps, that's it. You are set. You've done the answer correctly. One more example, and then if you want to have more work or more examples, you can have a look at the full length 20-minute version, okay? So what we're just going to look at is another example. This one, though, has a highest common factor. You need to make sure, even with completing the square, that we always take out the highest common factor first. So let's have a look. 7 and x squared. 7 goes in that. Does 7 go into 42? Yes, it does. Does 7 go into 14? Yes, it does. So let's take it out. So I've got 7 x squared plus 6x plus 2, okay? And then you actually should be checking, unless you're told to use completing the square, check, okay? So I'm going to check and I'm going to go, so what are the factors of 2, 1 and 2? Are they ever going to add to 6? No, they are not. So therefore, I can continue on. So at this point, I'm going to complete, okay? Highest common factor comes out first. Now I'm going to complete the square. Remember that you can do this on your calculator to give yourself some check methods as well, but we won't always have the calculator. So what I'm going to do now is I'm going to complete the first two terms to make them a perfect square. We always use the first two terms. So the 7 stays on the outside. I'm going to use a square bracket to show that everything in there will be multiplied by the 7, but I'm not going to worry about the 7 for now. So I've got x squared plus 6x plus something minus that same something and then plus 2, and then I'm going to close the square bracket. So everything inside the square bracket is being times by the 7. So what is that plus number? Remember, it is half of the middle term here. So half of this. So 6 on 2 squared, because I'm looking for a squared number. 6 on 2 squared. You don't need to leave it as a fraction right then if it's going to work out nicely. So obviously that's 3. If it doesn't work out nicely though, then leave it as a fraction. So if it's 5 on 2, for example, just leave it as 5 on 2. That's fine. Okay, so then I will keep going. So I've got 7. The next thing I'm going to do over here is what? Perfect square, right? So in my first portion there, now I know that I'm going to have x plus because I've got plus here. 6 over 2 is 3 squared. Let's try it. X by x gives me x squared. 3 by x by 2 gives me 6x. 3 squared is 9. 6 over 2 squared is also 9. So yes, I have now done this and moved it into brackets. I've factorized it. What is left? I've got minus 6 on 2, which is 3 squared, so minus 9 plus 2. Okay, now I keep going. I've got 7. Sorry. X plus 3 as my first square number there, minus 9 plus 2 minus 7. Okay, I've got 7 again. 7, same as in the last problem, is just surd, yeah? So surd 7 times surd 7 gives me 7. So I know that it was surd 7 that was squared to get there, so therefore I'm going to have plus surd 7 minus surd 7 as my second term. So I've just got 7. This time I can get rid of the square because I'm going to have 2 sets of brackets. What goes in those brackets? I've got x plus 3 at the beginning of both. Minus plus minus, doesn't matter as long as I've got one of each. Surd 7, surd 7. Done. Okay, so now I want you to do some examples of your own. Go into 2.5 and try out a variety if you haven't already done so. If you've done that, have a go at the practice test, have a look at the chapter review.